Your car is trying to tell you something. Strange noises, poor performance, or warning lights are all signs of trouble. Ignoring them could lead to costly repairs or even dangerous situations on the road. In this video, we'll uncover the warning signs of failing car components, starting with the thermostat. In today's video, we're breaking down one of the key components of your vehicle's cooling system, the thermostat. We'll cover its 5 major functions and 5 telltale signs that your thermostat might be going bad. Thermostat in a car engine plays a crucial role in regulating the engine's operating temperature. It controls the flow of coolant between the engine and the radiator to ensure that the engine runs efficiently and avoids overheating. Here are the 5 key functions of a thermostat in a car engine. Number 1. Temperature regulation. The primary function of a thermostat is to regulate the engine's temperature. It does this by controlling the flow of coolant between the engine and the radiator. When the engine is cold, the thermostat remains closed to prevent coolant from circulating to the radiator, allowing the engine to warm up quickly. Once the engine reaches the optimal operating temperature, typically around 195 degrees Fahrenheit to 220 degrees Fahrenheit or 90 degrees Celsius to 105 degrees Celsius, the thermostat opens, allowing coolant to flow and maintain a stable temperature. Number 2. Engine warm-up. The thermostat ensures that the engine warms up quickly after starting. In colder conditions, if coolant were allowed to flow to the radiator immediately, it would take much longer for the engine to reach its optimal operating temperature. A faster warm-up improves fuel efficiency, reduces emissions, and allows for better engine performance sooner. Number 3. Prevention of overheating. If the engine's temperature begins to exceed its safe operating range, the thermostat opens fully to allow maximum coolant flow to the radiator. This helps dissipate excess heat and prevent the engine from overheating, which can cause serious damage such as warped cylinder heads or engine failure. Number 4. Optimizing engine efficiency. By maintaining the engine at its optimal operating temperature, the thermostat helps to maximize fuel efficiency and minimize emissions. When an engine runs too cold, combustion is less efficient, leading to increased fuel consumption and higher emissions. By keeping the engine at the right temperature, the thermostat ensures that the engine operates at its most efficient point. Number 5. Preventing engine damage. Running an engine that is either too hot or too cold can lead to damage over time. If the engine is too cold, it will not burn fuel properly, leading to increased carbon buildup, poor lubrication, and excessive wear on internal components. On the other hand, overheating can cause damage to gaskets, seals, and metal components, leading to expensive repairs. The thermostat prevents these issues by ensuring the engine stays within the optimal temperature range, thus protecting the engine from potential damage. The thermostat is a critical component that ensures your car's engine runs efficiently, warms up quickly, avoids overheating, and stays protected from temperature-related damage. Now, let's talk about the signs of a failing thermostat. A failing thermostat in a car engine can lead to various performance and safety issues. When the thermostat malfunctions, it disrupts the cooling system's ability to regulate the engine's temperature, which can cause significant problems. Here are 5 key symptoms of a bad thermostat in a car engine. Number 1. Overheating engine. One of the most obvious signs of a bad thermostat is engine overheating. This happens when the thermostat gets stuck in the closed position, preventing coolant from circulating through the radiator to dissipate heat. If the thermostat doesn't open at the right temperature, the coolant remains trapped in the engine, causing heat to build up rapidly. Overheating can lead to severe damage to the engine's components, including warped cylinder heads, blown head gaskets, and, in extreme cases, complete engine failure. Number 2. Underheating, engine running too cold. An engine running too cold, indicated by a low temperature gauge reading, is another sign of a malfunctioning thermostat. If the thermostat is stuck open, coolant flows continuously between the engine and radiator, causing the engine to run colder than it should. This results in prolonged warm-up times, reduced fuel efficiency, poor heater performance, and increased wear on engine components due to improper lubrication and combustion. Number 3. Erratic temperature fluctuations. Unstable or fluctuating engine temperatures are a sign that the thermostat may be failing intermittently. When the thermostat is not functioning properly, it can open and close at irregular intervals, causing sudden and unpredictable temperature changes in the engine. The temperature gauge on the dashboard might show rapid spikes or drops, indicating inconsistent coolant flow, which can lead to engine performance issues or potential damage if not addressed. Number 4. Coolant leaks. Coolant leaks around the thermostat housing or other parts of the cooling system can be a symptom of a thermostat issue. A faulty thermostat can cause the engine to overheat or create excessive pressure in the cooling system, leading to coolant leaks at weak points, such as the gasket around the thermostat housing. In some cases, a failing thermostat can cause the coolant to back up into the overflow reservoir or spill onto the ground, which is a clear indication of a problem with the cooling system. Number 5. Poor heating in cabin. If you notice that your vehicle's heater is blowing cool or lukewarm air despite the engine being at normal operating temperature, it could point to a thermostat problem. When the thermostat is stuck open, the engine may not reach its optimal temperature. Since the heater relies on hot coolant from the engine to generate heat inside the cabin, a cold running engine results in insufficient warmth being transferred to the heater core, making the cabin heater ineffective. If this video was helpful, please hit subscribe button and turn on the notification bell for more car maintenance tips. Thanks for watching. Your brake master cylinder controls brake fluid pressure, and when it fails, braking power is compromised. Look out for these symptoms. 8 symptoms of a failing brake master cylinder. A spongy or soft brake pedal feels mushy and lacks firmness when pressed. Instead of providing immediate resistance, the pedal may sink gradually or require more effort to engage the brakes effectively. This can make braking feel unpredictable and less responsive, increasing stopping distances and making it harder to control the vehicle safely. The issue may worsen over time, leading to a situation where the pedal eventually reaches the floor without fully engaging the brakes. Number 2. Brake fluid leaks. You may notice brake fluid pooling under the vehicle, typically near the firewall or beneath the master cylinder. The fluid may also appear around the brake booster or inside the engine bay. A drop in the brake fluid reservoir level can indicate a leak, which may lead to reduced braking efficiency and increased stopping distance. The brake pedal might also feel soft or spongy due to the loss of hydraulic pressure. Number 3. Contaminated brake fluid. When brake fluid becomes contaminated, it can change color, turning dark brown or black instead of its usual clear or light amber appearance. This contamination can reduce the fluid's effectiveness, leading to poor braking performance, increased stopping distances, or a spongy brake pedal. Contaminated fluid can also cause internal brake components to wear out faster, potentially leading to costly repairs. Regular brake fluid checks and timely replacements help maintain optimal braking efficiency. Number 4. The brake warning light on your dashboard illuminates to alert you to a potential issue within the braking system. It may appear as a red or yellow symbol, often depicting an exclamation mark inside a circle or the word brake. This light can turn on while driving or remain illuminated after starting the vehicle. Depending on the car model, it may also be accompanied by an ABS warning light if the system detects a related issue. If the brake warning light stays on, it is essential to inspect the braking system immediately for safety reasons. Number 5. Inconsistent braking performance. If your brakes feel strong one moment and weak the next, you may be dealing with inconsistent braking performance. This can make it difficult to predict how much pressure is needed to stop the vehicle, increasing the risk of accidents. Uneven braking can also make driving stressful, especially in emergency situations where reliable stopping power is crucial. If you notice fluctuating brake responsiveness, it's time to get your system inspected. Number 6. Brake sticking or dragging. When this happens, the wheels do not release fully after you take your foot off the brake pedal. You may notice increased resistance while driving, reduced fuel efficiency, or excessive heat coming from the wheels. In severe cases, the vehicle may feel like it's slowing down on its own or pulling to one side. Over time, this can lead to premature brake wear and possible damage to other braking components. Number 7. Unusual brake pedal behavior. The brake pedal may feel different from its normal operation, making it harder to control braking. You might notice that the pedal is overly stiff, requiring excessive force to engage the brakes. In some cases, the pedal may become unresponsive, failing to return to its original position after being pressed. This irregular behavior can make braking unpredictable, leading to delayed or inconsistent stopping power. Additionally, the pedal may engage too high or too low, disrupting the usual feel of the braking system and making it difficult to gauge the necessary pressure for safe stopping. Number 8. No brakes or complete brake failure. A total brake failure is one of the most dangerous situations a driver can face. When this happens, pressing the brake pedal produces little to no response, leaving the vehicle unable to slow down or stop. This can occur suddenly or worsen gradually, depending on the severity of the issue. In such cases, the vehicle may continue moving even when the driver attempts to apply the brakes. This significantly increases the risk of accidents, especially in traffic, downhill roads, or emergency situations where stopping power is crucial. If you experience a loss of braking, it's important to stay calm and take immediate action. Pumping the brake pedal may help regain some pressure if there is still fluid in the system. Downshifting to a lower gear and using the handbrake, parking brake, can also help slow the vehicle down. If safe to do so, steering towards an open area or using barriers like curbs or guardrails to reduce speed may be necessary in extreme cases. Because complete brake failure poses a severe safety risk, it is critical to inspect the braking system at the first sign of trouble and seek professional repairs immediately. Your brakes are your car's most vital safety feature. If you notice any of these warning signs, don't wait, have your braking system checked by a professional. If you found this video helpful, give it a thumbs up and don't forget to subscribe for more car maintenance tips. The exhaust gas recirculation (EGR) valve reduces emissions, but when it fails, performance and fuel efficiency suffer. Here are the warning signs, 8 symptoms of a bad EGR valve. An EGR exhaust gas recirculation valve is a critical component in many modern engines that recirculates a portion of the exhaust gases back into the engine's intake manifold, reducing nitrogen oxide NOx emissions. By doing this, the EGR valve helps the engine operate at a lower temperature, which results in cleaner emissions and improved fuel efficiency. Here is an expanded explanation of each symptom associated with a faulty EGR exhaust gas recirculation valve. Number 1. Rough idle. When the EGR valve gets stuck in either an open or closed position, it disrupts the air-fuel ratio entering the engine. If the EGR valve remains open at idle, exhaust gases continue to flow back into the intake manifold, leading to an improper mix. This can cause the engine to run roughly, leading to a shaky or erratic idle, often noticeable when the vehicle is stationary. Number 2. Engine knocking or pinging. The EGR system is designed to help regulate combustion temperature by reintroducing exhaust gases into the combustion chamber. When the EGR valve fails, combustion temperatures can increase, causing knocking or pinging sounds, especially when the engine is under load or accelerating. Persistent knocking can damage the engine if not addressed. Number 3. Poor acceleration. If the EGR valve is stuck open, too much exhaust gas may flow into the engine, depriving it of the oxygen needed for combustion. This leads to poor acceleration response and a general lack of power. On the other hand, if the valve is stuck closed, the engine may experience excessive temperature and other issues, reducing its ability to accelerate smoothly and quickly. Number 4. Increased emissions. One of the EGR valve's primary roles is to reduce nitrogen oxide NOx emissions, which are harmful pollutants. A malfunctioning EGR valve often results in increased NOx emissions because the combustion temperature becomes too high without proper exhaust gas recirculation. Higher NOx emissions can cause the vehicle to fail emissions tests, and it contributes to smog and air pollution. Number 5. Check engine light. When there is a problem with the EGR valve or related components, the vehicle's computer system detects it and activates the check engine light. Diagnostic trouble codes related to the EGR valve, often in the range of P0 for 00 to P0 for 08, may appear, indicating issues such as valve stuck open, valve stuck closed, or insufficient EGR flow. Number 6. Reduced fuel efficiency. A faulty EGR valve can disrupt the air-fuel mixture, causing the engine to burn fuel inefficiently. If the EGR valve is stuck open, it can introduce excess exhaust gases, reducing combustion efficiency and making the engine work harder to produce power. This can lead to increased fuel consumption, as the engine requires more fuel to achieve the same output. Number 7. Engine stalling. An EGR valve stuck open at idle allows exhaust gases into the intake manifold, disturbing the fuel-air mixture and potentially causing the engine to stall. This is often most noticeable when the vehicle is idling, especially after it has warmed up. Stalling at low speeds or when stopped can be a safety issue and is often a sign of EGR-related problems. Number 8. Engine overheating. The EGR valve is crucial for controlling combustion temperatures. If the valve is stuck closed, the lack of recirculated exhaust gases can cause higher than normal temperatures within the combustion chamber. Prolonged overheating may lead to severe engine damage, including warping of engine components or even complete engine failure. These symptoms can vary depending on the severity of the EGR valve issue and whether it's stuck open or closed. Not addressing a faulty EGR valve can lead to more severe engine issues and decreased overall vehicle performance. Thanks for watching. If you found this video helpful, please like, subscribe, and turn on notifications for more car maintenance tips. Fuel injectors deliver the precise amount of fuel to your engine. When they fail, engine performance drops. Watch for these symptoms: fuel injectors, functions, importance, and failure symptoms. Let's get started. What is a fuel injector? A fuel injector is a device in a car's engine that sprays fuel into the combustion chamber. It is a part of the fuel delivery system and is controlled by the car's engine control unit, ECU. The injector atomizes the fuel, mixing it with air to ensure efficient combustion. This process is critical for the engine's power, efficiency, and emission control. Let's look at the 5 main functions of fuel injectors. Number 1. Fuel delivery precision. Fuel injectors ensure precise delivery into the combustion chamber or intake manifold. This precision is essential for optimizing engine performance and efficiency, as it allows the engine to receive the right amount of fuel needed for combustion at any given moment. Number 2. Atomization. Fuel injectors atomize liquid fuel into fine mists or droplets. This atomization process is vital because it facilitates better fuel mixing with air in the combustion chamber. The finer the fuel droplets, the more evenly they mix with the air, promoting efficient combustion and reducing emissions. Number 3. Timing control. Modern fuel injectors are electronically controlled, allowing for precise timing of fuel delivery. This timing synchronization ensures that the fuel is injected into the combustion chamber when needed, corresponding to the engine cycle. This synchronization is crucial for optimizing power output, fuel efficiency, and minimizing emissions. Number 4. Emissions control. Fuel injectors play a significant role in emissions control by delivering fuel in precise amounts and at exact times. This precision helps engines meet stringent emissions regulations by ensuring complete combustion of fuel, thereby reducing harmful exhaust emissions such as hydrocarbons, HC, carbon monoxide, CO, and nitrogen oxides, NOx. Number 5. Durability and reliability. Modern fuel injectors are designed to withstand high pressures, varying temperatures, and harsh operating conditions within the engine. They are built with durable materials and advanced engineering to ensure longevity and reliability. This durability is essential for maintaining consistent performance over the vehicle's lifespan and reducing maintenance costs. In summary, fuel injectors are integral to the operation of modern engines due to their precise fuel delivery, atomization capabilities, timing control, emissions reduction, and overall durability. Understanding these functions not only helps us appreciate their importance in optimizing engine performance, fuel efficiency, and environmental sustainability, but also empowers us to recognize and address potential issues, saving us from costly repairs and ensuring our vehicles run smoothly. Next, let's discuss why fuel injectors are so important the importance of fuel injectors in modern engines cannot be overstated, as these components play critical roles in various aspects of engine performance, efficiency, and environmental impact. Number 1. Engine performance. Fuel injectors directly influence engine performance by ensuring that the engine receives the precise amount of fuel needed for combustion. This precise fuel delivery optimizes power output, throttle response, and overall engine smoothness. Engines equipped with fuel injectors typically exhibit better acceleration, smoother idling, and consistent performance across different operating conditions. Number 2. Fuel efficiency. Efficient fuel injectors contribute significantly to fuel economy by delivering fuel in precise amounts and at optimal times. This precision reduces fuel waste and ensures that the engine operates at its peak efficiency. As a result, vehicles equipped with well-functioning fuel injectors tend to achieve better mileage and reduce fuel consumption, translating into cost savings for the vehicle owner. Number 3. Emissions compliance. Fuel injectors are crucial in reducing harmful vehicle emissions. By delivering fuel precisely and facilitating complete combustion, fuel injectors help engines meet stringent emissions regulations. They contribute to reducing emissions of pollutants such as hydrocarbons, HC, carbon monoxide, CO, and nitrogen oxides, NOx, thus promoting cleaner air and environmental sustainability. Number 4. Reliability and durability. Modern fuel injectors are designed to withstand the harsh conditions within an engine, including high temperatures and pressures. Their robust construction and materials ensure durability, reliability, and longevity. This reliability translates into fewer maintenance issues related to fuel delivery, reducing downtime and repair costs for vehicle owners. Number 5. Technology advancements. Fuel injectors are integral to the advancements in engine technology, including turbocharging and direct fuel injection. These technologies rely on precise fuel delivery provided by fuel injectors to achieve higher power outputs, improved fuel efficiency, and reduced emissions. The evolution of fuel injector technology continues to drive innovations in automotive engineering, contributing to more efficient and environmentally friendly vehicles. In conclusion, fuel injectors are essential components in modern engines, impacting engine performance, fuel efficiency, emissions compliance, reliability, and technological advancements. Their importance extends beyond simple fuel delivery, shaping the overall performance and environmental footprint of vehicles worldwide. Understanding and maintaining fuel injectors are crucial for maximizing engine efficiency, reducing operational costs, and promoting sustainable transportation solutions. Symptoms of a failing fuel injector. Now, let's explore the symptoms of your fuel injector failing. Number 1. Engine misfires. One of the most common signs of failing fuel injectors is engine misfires. Misfires occur when the injector fails to deliver the right amount of fuel or delivers it inconsistently. This can result in rough idling, hesitation, or jerking sensations while accelerating. Misfires can also lead to increased exhaust emissions and reduced engine performance. Number 2. Rough idle and stalling. Faulty fuel injectors can cause the engine to idle roughly or even stall. A rough idle is characterized by vibrations or uneven engine RPMs when the vehicle is stationary. Stalling may occur when the injector fails to deliver enough fuel during idle conditions, causing the engine to shut down unexpectedly. Number 3. Decreased fuel efficiency. If fuel injectors are not functioning properly, they may deliver too much or too little fuel to the engine, resulting in decreased fuel efficiency. You may notice that your vehicle is consuming more fuel than usual for the same driving conditions. This inefficiency can also contribute to higher fuel costs over time. Number 4. Engine performance issues. Failing fuel injectors can lead to noticeable performance issues such as decreased acceleration, loss of power, or difficulty in starting the engine. These symptoms occur because the engine isn't receiving the optimal amount of fuel needed for efficient combustion and power generation. Number 5. Check engine light, CEL, and diagnostic trouble codes, DTCs. A persistent check engine light on the dashboard is often triggered by issues related to fuel injectors. Modern vehicles are equipped with onboard diagnostics that monitor injector performance. When a problem is detected, the Engine Control Unit (ECU) may store diagnostic trouble codes (DTCs) related to fuel injector faults. These codes can be retrieved using a diagnostic scanner to pinpoint the exact issue. Identifying and addressing these symptoms promptly is crucial to prevent further damage to the engine and ensure optimal vehicle performance. Regular maintenance and inspection of fuel injectors can help detect issues early and avoid costly repairs down the road. Understanding fuel injectors and their role in your vehicle is essential for maintaining optimal performance and efficiency. If you notice any symptoms of a failing injector, it's crucial to get it checked and repaired by a professional. If you found this video informative, don't forget to give it a thumbs up and subscribe to our channel for more automotive tips. And remember, a well-maintained fuel injector is the key to a reliable car. Drive safe. Your radiator prevents your engine from overheating. If it fails, your car is at risk. Watch out for these warning signs. A car radiator is a crucial component of the vehicle's cooling system. It helps regulate the engine's temperature by dissipating excess heat generated during operation. The radiator consists of a series of thin tubes and fins through which coolant flows. Here's how it works. Number 1. Coolant circulation. Coolant absorbs heat from the engine and circulates through the radiator. Number 2. Heat dissipation. As the coolant passes through the thin tubes in the radiator, the heat is transferred to the fins. Number 3. Airflow. Air flows over the fins, usually driven by a fan or the car's forward motion, which cools the fins and, in turn, the coolant. Number 4. Cooled coolant. The now cooled coolant is recirculated back to the engine to absorb more heat. By maintaining the engine at an optimal temperature, the radiator prevents overheating, ensuring the engine runs smoothly and efficiently. Having learned what a car radiator is, let us discuss the primary functions of a car radiator in your car engine. The radiator in a car engine serves several essential functions to ensure the engine operates within its optimal temperature range. Here's a detailed explanation of its functions. Heat dissipation in a car radiator. Under heat dissipation, we have the primary functions and the process, and they are number 1. Heat absorption. The radiator's primary function is to dissipate the heat absorbed by the coolant from the engine. As the engine operates, it generates significant heat due to fuel combustion and friction. This heat needs to be managed to prevent engine damage. Number 2. Heat transfer. The radiator facilitates the transfer of this heat from the coolant to the surrounding air. The radiator is designed with numerous thin tubes and fins to maximize the surface area for efficient heat exchange. Number 3. Heat release. By dissipating the absorbed heat, the radiator ensures that the coolant is cooled down before it circulates back to the engine, maintaining its optimal operating temperature. The process entails how the coolant flows. It circulates through the engine, absorbing heat as it moves through the engine block and cylinder head. This heated coolant then travels through the hoses to the radiator. Number 2. Heat exchange in radiator. Inside the radiator, the coolant flows through a network of thin tubes. The large surface area of the tubes and fins allows the heat to transfer from the coolant to the radiator's metal. Number 3. Airflow and cooling. Air flows over the radiator fins, either through the vehicle's movement or with the aid of cooling fans. This airflow removes heat from the radiator fins, cooling the coolant. The cooled coolant is then pumped back into the engine to absorb more heat, completing the cycle. This continuous process ensures the engine remains within a safe temperature range, preventing overheating and maintaining efficient engine performance. The next point we will discuss is maintaining optimal engine temperature. Let us start with temperature regulation. Number 1. Thermostat control. The cooling system includes a thermostat that monitors the engine's temperature. When the engine reaches a certain temperature, typically around 195 degrees Fahrenheit or 90 degrees Celsius, the thermostat opens, allowing coolant to flow into the radiator. Number 2. Coolant flow regulation. The thermostat regulates the coolant flow based on engine temperature. When the engine is cold, the thermostat remains closed, directing coolant circulation primarily within the engine to aid in warm-up. As the engine warms up, the thermostat gradually opens, allowing coolant to flow through the radiator for cooling. Number 3. Maintaining optimal range. The thermostat's function ensures that the engine operates within its optimal temperature range. This range is critical for engine efficiency, emissions control, and longevity. If the engine temperature drops too low or rises too high, the thermostat adjusts the coolant flow to bring it back to the optimal range. The cooling cycle. Number 1. Coolant circulation. The cooling cycle begins with coolant circulating through the engine, absorbing heat generated by combustion and friction. The coolant absorbs this heat and carries it away from critical engine components. Number 2. Air cooling. Airflow over the radiator, either through the vehicle's movement or electric fans, carries heat away from the radiator's fins. This process cools the coolant inside the radiator, lowering its temperature. These processes work together to maintain the engine's temperature within the optimal range, ensuring efficient combustion, reducing emissions, and preserving the longevity of engine components. Effective temperature regulation and a well-functioning cooling cycle are essential for the overall performance and reliability of the vehicle. The next function of a radiator is to prevent engine overheating. Number 1. Design of radiator. The radiator has numerous thin tubes and metal fins, providing a large surface area for heat transfer. This design maximizes the contact area between the hot coolant and the cooler air, allowing for more efficient heat dissipation. The efficiency of this heat exchange is crucial in preventing the coolant from retaining too much heat and subsequently overheating the engine. Number 2. Material choice. Radiators are typically made from materials with high thermal conductivity, such as aluminium or copper. These materials efficiently transfer heat from the coolant to the air, ensuring that the heat absorbed from the engine is quickly and effectively dissipated. This rapid heat transfer helps maintain a stable engine temperature and prevents overheating. The airflow. Number 1. Vehicle movement. As the vehicle moves, air naturally flows through the grille and across the radiator surface. This airflow removes heat from the radiator fins, enhancing the cooling process. The faster the vehicle moves, the more air flows through the radiator, increasing the heat dissipation rate and helping to keep the engine temperature in check. Number 2. Cooling fans. When the vehicle is stationary or moving slowly, electric or mechanical cooling fans provide additional airflow over the radiator. These fans are controlled by the engine's temperature sensors and activate when needed to ensure continuous air movement across the radiator fins. This consistent airflow is vital for maintaining cooling efficiency, especially during idle or low-speed conditions, preventing the engine from overheating. These aspects of heat exchange efficiency and airflow work together to ensure that the engine remains within its optimal temperature range, effectively preventing overheating and maintaining reliable engine performance. We will now discuss the symptoms of a bad radiator in a car engine. A bad radiator can cause several symptoms that indicate potential problems with the car's engine cooling system. Here are common symptoms to look out for. Number 1. Overheating. The most obvious symptom is engine overheating. If the radiator is not functioning properly, it cannot effectively dissipate heat from the coolant. This can lead to the engine temperature rising above normal levels, which may trigger warning lights on the dashboard or cause the engine to overheat and possibly shut down. Number 2. Coolant leaks. A leaking radiator can result in coolant dripping or pooling underneath the vehicle. You may notice puddles of coolant when the car is parked. Coolant leaks can occur from cracks in the radiator tank, damaged hoses, or corroded fittings. Loss of coolant can lead to overheating and potential engine damage if not addressed promptly. Number 3. Low coolant levels. If you frequently find yourself needing to top up the coolant reservoir or notice the coolant level dropping without any visible leaks, it could indicate a problem with the radiator. A faulty radiator cap or internal leaks within the radiator could cause coolant to escape, leading to low coolant levels. Number 4. Visible damage. Inspect the radiator visually for any signs of physical damage, such as cracks, corrosion, or bent fins. Damage to the radiator structure can impair its ability to cool the coolant efficiently. Number 5. Engine misfire or poor performance. In severe cases of overheating or coolant loss, the engine may experience misfires, reduced power, or poor acceleration. This occurs when the engine's operating temperature becomes too high, affecting combustion efficiency and overall engine performance. If you notice any of these symptoms, it's important to have the radiator and cooling system inspected and repaired by a qualified mechanic. Ignoring radiator issues can lead to costly engine damage and potentially unsafe driving conditions. So, there you have it. If you like my video, please hit the subscription button and turn on the notification bell to get my video when it drops. Thank you.